Hello, Year 8. For our final lesson on fractions for this week, we are going to look at fractions with algebra. Possibly everyone's two favourite topics, algebra and fractions. What could possibly go wrong? So the aim for today is we are going to try and add and subtract algebraic fractions. Why are we going to do this? Well, as we progress through the course and through into the GCSE, you might have equations that you have to solve that have fractions. So being able to manipulate algebra and fractions becomes quite important. However, the maths that we're going to need today isn't massively different from when we were adding and subtracting fractions earlier in this topic. We will need a common denominator. The common denominator could be a number, it could be an algebraic expression. But to get us started with algebraic fractions, let's look at a few examples where the denominators are the same. So we know when the denominators are the same in fractions, we can just add the numerators. So for example, in this first example, I have got x over 5 and 2x over 5. So if this was just numbers, I would be adding these numbers here and putting the fraction over 5. Well, all we have to do this time is add the algebra. And x, add another 2 x's, is 3x. So the answer to this one is just 3x over 5. Similarly, on my second fraction, you can see the denominators are already the same, so I can just subtract my numerators straight away. And if I have 3y's and I subtract another y, I would be left with 2y's. So this is just like collecting terms. 2y over 8. Now, you might think this simplifies, and you would be right to think that it simplifies because the numerator and the denominator can both be divided by 2, so this one would simplify to y over 4. So all I have done is divided the numerator and the denominator by 2, just as if we were cancelling fractions normally. Now, sometimes when you add algebraic fractions, the answer can sometimes look a little bit strange. Sometimes you can think the answer looks more complicated than what you started with. Because here, in this fraction 2a over 7, add b over 7, I have two different variables, a and b. When I come to add this together, well, there's no way of writing 2a add b in a simplified form. So the answer to this one is just 2a plus b over 7. So how about some questions where the denominators are different? Well, in these questions, we'll have to do the same thing as if we're adding and subtracting normal fractions. We need a common denominator. So if possible and you can get away with just multiplying one of the fractions, that's great, we'll just multiply one of them. Sometimes you might have to multiply both of the fractions. Now I can see I've got one denominator of 8 and another denominator that is 2. So if I multiply this first fraction, the top and the bottom, by 4, it will make the denominator 8. So I'm just going to write that at the side, that I'm timesing the numerator and the denominator of this first fraction by 4. What does that become then? Well, I do x times 4, which is just 4x, and 2 times 4, which is 8. So x over 2 is the same as 4x over 8. And if I subtract an x over 8, I will be left with 3x's over 8. We've got 5y over 12 and 3y over 4. Can you see which one of these fractions needs multiplying? We can find the common denominator by multiplying this second fraction by 3. If I multiply the top and the bottom by 3, this will be 12. So let's do that. I can leave the first fraction alone, 5y over 12. And if I multiply the numerator and denominator by 3, well, 3y times 3 is 9y. And 4 times 3 is 12. Now that the denominators are the same, I can add the numerators. If I had 5y and another 9y, well, altogether that is 14y. You might have spotted that this fraction can simplify. We can divide the top and the bottom by 2. So I can write this one as 7y over 6. I know what some of you might be thinking. It's an improper fraction. Would I write it as 1 1/6 of y? Well, you could do, but it's normal to leave, when you're working with algebra, these sorts of fractions as improper fractions. So if you see any of those today, I will be leaving them as improper fractions. In my third example, I need to find a common denominator for 3 and 5. I have to multiply both of them on this. I'm going to times the first fraction, top and bottom, by 5. And on the second fraction, I'm going to multiply the numerator and denominator by 3. And that will make the common denominator 15 for both of these. I've got a subtraction. So let's do that. A times 5 would be 5a. And 2b times 3 would be 6b. Now notice that this is an example where I've got two different variables, so I can't simplify that. I can only write it as 5a minus 6b all over the common denominator of 15. Now sometimes you can have a little bit extra floating around on your numerator, so I just thought we'd have a look at one of these ones. Is there a common denominator for 2 and 4? Yes, the common denominator would be 4. So I can leave this first fraction alone, but I would need to times the top and the bottom by 2 on the second fraction. So this remains a over 4. The denominator here is going to become 4, but now I've got to multiply both of these bits by 2. So I'm going to get an a times 2, which is 2a's, and I've got this plus 1 that I need to multiply by 2, which is plus 2. If I collect these numerators together, well, I can collect the a's, and a and 2a would make 3a, but I have just this plus 2 by itself, which is something completely different. So my numerator is 3a plus 2 all over 4. Let's look at some final examples that are getting a little bit more challenging still. So I've got x plus 1 over 3 plus x take away 3 over 6. Can you see a common denominator? Yes, the common denominator is 6, so I can leave this one alone, but I need to multiply the numerator and denominator of this one by 2. If I times everything by 2, I'm going to have 2x's plus 2 over 6 plus, this one stays the same, x take away 3 over 6. Let's combine the numerators. Well, I can collect the 2x and the x, that's 3x, and I can collect the plus 2 and the minus 3, and plus 2 minus 3 is negative 1. Now, in my final 3 examples, I've gone for something a little bit different. No longer are the denominators just numbers. So to find the common denominator for these ones is a little bit more complicated, and it's an algebraic expression. So what you need to say is, what is the common denominator of x and y? Well, the answer to that is xy. I can multiply these two things together to find the common denominator and write it as a single expression. So what you need to think about now is, if I'm doing that, what have I multiplied this first fraction by to make the denominator xy? Well, I've already got the x, so I must have times that first fraction by y. Similarly, in the second fraction, I've already got the denominator of y, so I must have multiplied by x. So let's now multiply the numerators. If I've multiplied this one by y, this one is 6y. And if I've multiplied this one by x, this numerator is 2x. Putting it all over a common denominator, it is 6y plus 2x. Now, as I've gone through that example, if you're thinking it's starting to get a little bit complicated here, sir, do not panic. Do not panic, particularly if you are in set 2, because obviously when you try some questions in a minute, you will be able to start on level 1 and level 2, and they will not be as challenging as some of these further examples. So please do not panic. Obviously, if you're in set 1, I'm hoping that you're currently understanding what I'm talking about. So what could be a common denominator for 1 over x minus x over 7? I'm going to use that same idea. If I multiply these two things together, that would be a common denominator. So I'm going to be able to write them both as fractions of 7x. But what have I times each one by? Well, this one already had the x, so I'll need to times this one by 7. This one already had the 7, so to become 7x, I would have to times it by an x. So what is going to happen to my numerators? Well, 1 times 7 is 7, but how do I write x times x? This one would be x squared. So I can write this answer as 7 minus x squared, combining my numerators, over 7x. Final example. Now, some of you might be thinking, oh yeah, I've followed what you've done, sir. We can just multiply these two things together for my common denominator. Now, you don't always need to do that. These already have an x in common. So I can actually get away with just multiplying each of these by a number to make the denominator the same. I can make the common denominator be 10x. So what have I multiplied by? I've multiplied this fraction, the numerator and denominator, by 5, and this one by 2. If I now do likewise to the numerators, y times 5, 5y. 6 times 2, 12. Now there's no way of collecting and tidying up 5y add 12, so I just write this one as 5y add 12. So there are some questions for you guys to try. This time I've put the questions on a question sheet. I've had to make a few questions of my own. So it's going to be quite difficult to read the questions from the video, so I would suggest you go back to my instructions and you open up the question sheet. There are 3 levels of questions, but I've also done some super difficult ones for those that would like a little bit of extra challenge. As always, if there are any problems, you can ask in the Ask the Teacher channel. See how you get on today.